Hey, good evening, everybody. Welcome to the forecast program here. There's a little bonus clip there showing some of the clouds there off the California coast. And that just shows mostly a lot of marine stratus offshore there with a little bit of cirrus. We do have thunderstorms on the Great Plains. And there they are right there. Just west of North Platte, all the way down towards, I guess that would be northwest of Burlington there. Tail end storm in that area. And I'm going to go ahead and load up GR level 2, and we'll take a detailed look at that. So let's get that all set up here. We're going to set up the, I guess we're going to have to use the North Platte. Yeah, let's head out there. That might be a little bit too far north. I guess we'll do Goodland here. Okay, so the data will start coming in, and while that's doing that, let's take a look at the other maps. And sorry to go back and forth, but the maps already came in. So there's our storms up in southwestern Nebraska and northeast Colorado. These appear to have a little bit of rotation on them. The tail end storm right here, this is south of Yuma. You can definitely see that notch in there, so this is likely has a little bit of rotation. We got to keep in mind the radar is to the southeast there. So let's look at the velocity. Sometimes it's good to start with the base velocity so you can kind of see what the basic velocity product is doing before you progress into the storm relative products. So what do we see here? Looks like a little bit of an inflow, or not inflow, but flow towards the radar right there. That's going to be associated with the RFD area. And then we have some weak flow going away from the radar like that. So this appears to be on the order of about 15 knots versus 15 knots, so about 30 knots a shear there. So that's not particularly strong there. I wouldn't expect there to be a tornado in that, but I don't even think there's the need to go to storm relative velocity. Those that couplet there is pretty well balanced. So it looks like we've just got kind of a hailer there out there in Colorado. Definitely see some very high reflectivities on that storm. The other cells look pretty similar. This has the appearance of maybe a left mover. And it appears that it is moving towards the northeast there. So, and then further up the line, we've got another strong storm and a couple of others further up into Nebraska. So we'll come back and look at those in a bit here. So on to the synoptic pattern. There's what the national map looks like, and I've overlaid the mixing ratio in green, and that's basically the moisture. So there's the higher values out there in the Gulf of Mexico. Also some higher values starting to show up in the lower plains around Wichita, Tulsa, Oklahoma City, and Dallas. And then we see the dry air mass out in this region here. So just going by this, we can kind of outline where that dry line is. So at first glance, it's going to be in western Kansas and the Texas Panhandle. And looks like we have a triple point up there in Nebraska. So let's take a closer look at that area there. That's not close enough. Let me zoom that in further. That's a little better there. We want to get down to the mesoscale so we can see some of the processes that are helping to feed these storms here. So I'm going to go ahead and overlay the counties. And we'll also outline the highways. And I'll try to save some of these maps so we can use them tomorrow. All right, so we're good to go here. There's the data. Very warm temperatures there in southwestern Nebraska, and we see that the dew points in that area are kind of on the high side there. Let's see if we can get a little bit of radar data going. Kind of throw that in there too. We'll use Goodland, North Platte, Denver, and Dodge City. So let's bring in that radar data and overlay that. Okay, so this should give us the storms there. Looks like a clear air return right there in south central Nebraska. And now we can overlay the plots here. So it looks like the dew points feeding those storms are confined mostly to the lower 50s. One little area here, 57 dew points around North Platte. And where's the dry line? Let's try to find that. It is just not very well defined. Let me move this around so you guys can see. 45, 58, 50. Yeah, I'm just going to kind of go maybe something like this here. And that feeds back up towards western Nebraska. And let's see if we can find any thermal boundaries. Yeah, there's definitely one. See this area right here? That's that backdoor cold front there in eastern Nebraska. Got a cool northeast flow back there at Omaha and Des Moines. And looks like that kind of arcs around. North wind there at Denver. Northwest wind at Colorado Springs. And that gives us our frontal boundary. So, yeah, looks like we got a bit of a baroclinic low right there in the Nebraska Panhandle. And any other boundaries? I don't think so. So, yeah, we're mostly just lacking good moisture. So I think we would probably have some tornadoes on the ground if our dew points were about 5 to 10 degrees higher here. And speaking about tornadoes, let's look at the weather products. We'll go to SPC. We have an enhanced risk area there for that area of storms. Severe thunderstorm watch. And mesoscale discussions, we got a few of those. And they're all talking about severe watches. So looks like they're just going to kind of reorganize those watch boxes out there in Nebraska. So they're going to remain organized for the next few hours at least. Dew points in the mid-50s, southeast surface winds. So yeah, the southeast surface winds, that's a good point there. We've likely got a fairly decent shear setup here. So that's likely helping with those rotating structures, but we just don't have what we need for that last mile there to get the tornadoes going. All right, let's look at the thickness and isobars. Here's what it looks like this evening. That very strong front that we had yesterday in Manitoba and Ontario, that has moved southeast. There it is heading towards Lake Ontario and Lake Erie. Warm front extending off Labrador, and we've got, looks like another front in the Great Basin area, somewhere in there. Got some very cool air in Washington and Oregon. And you can see the thickness gradient back in this region right here. There's at least 4 or 5 lines, but very little out ahead of it. The lines are just kind of a little bit disorganized there. And then we can see the start of that lee side troughing there in Colorado. That's a lee side low right there. And then buried in this area here in that little corner, that's going to be our baroclinic low right in that area. So let's outline all this. There's our warm front that jives with our surface analysis. This analysis is not fine enough to resolve that front that we had across central Colorado, but we can kind of connect that back towards Utah and Nevada like that. So very likely it extends back into this area. So does that match up with the Weather Prediction Center? Yeah, it kind of does. There's that frontal boundary right there. They analyzed another front there in Montana with that little inverted trough right there. So yeah, that would probably also be a front there. Let's go to the upper air and see what's going on. Looks like things are definitely getting more active. We're getting rid of this pesky ridge. So there's a medium scale ridge right there. That's helping to keep some subsidence on the Great Plains right there, but not enough to keep those storms there from forming. We've got cyclonic flow moving into the western U.S. right there. There's a good trough moving through northern California. And we're bringing in that polar front jet into the northwest U.S. right there. Let's take a look at 700 millibars. Got about 7 degrees Celsius at 700 where we have those storms there. So the capping is definitely a little bit weaker in that area. And then that little tail end of those storms, they extend down towards Burlington. And looks like the cap is a little stronger in that area, probably up to about 8 or 9. So that's about the cutoff for those storms there. Definitely nothing along that dry line in Kansas. And then you can see the mid-level temperatures very warm in the Texas Panhandle, almost 60 degrees up there at 10,000 feet. And then at 850, check out the moisture situation. And it still looks very dry. Minus 12 at Fort Worth, minus 7 at Corpus Christi, but the moisture is starting to flow through Del Rio. 12 Celsius there. That's going to be mid-60s, or I'm sorry, mid-50s dew points. And then we've got some upper 40s dew points through that area right there. So the moisture is coming up. Just a quick isodrosotherm is going to look something like this. And then the deeper moisture lurking back in that area. So it is on the move there. Wow, minus 11 dew point there at Lake Charles. So, yep, dry air just above the lower levels there. So, yeah, why don't we take a look at a couple soundings. I think it's been a couple days since we've done that. Let's try Fort Worth first and work our way northward. So there's the current Fort Worth sounding, showing lots of capping there. 700 millibar temperature, 11 Celsius there. And if we had a temperature of, say, 86 with a dew point of 60, we'll just assume it's a little more moist than it actually is. We lift the parcel and we've got a nuclear cap here. There's no way that will break. And convective inhibition, minus 684 using standard temperature and minus 550 using virtual temperature there. So, yeah, that's a very significant cap there. Let's go up north to Omaha, or Norman. Big difference there. Cap weakens a little bit right there, but also moisture is on the weak side. Go up to Dodge City. That may bring us a little bit west of the dry line. A little bit of moisture there. So maybe we're not quite west of the dry line there. We're just dealing with a very weak, moist sector. And then going up to North Platte, that's probably going to be just out ahead of those storms. For the Central Plains, especially up there in Nebraska, that moisture doesn't look too bad, but it is weak. And then lifting our parcels, you can see the cap is on the moderate, weak to moderate side. And then here's our cape right there. A little bit long and skinny there. But some very good 700 to 500 millibar lapse rates right there. And we can see the moisture field definitely got directional shear there. But we're going to take a look at the hodograph. We'll jump over to the NAM here in a second and look at this in more detail. I don't know, maybe this is a good time. Let's do that right now. We'll use the high-resolution rapid refresh. Let's do that. I'm going to sample just out ahead of these storms, like right around here, south of North Platte. Let's look at the environment. And this will give us that photograph. Doesn't look too bad there. You can see the hook shape. So that's definitely pretty conducive there to rotating storms. The sounding here still not very good at all, but let's see what the storm out velocity looks like. 124 for surface through 1 kilometer and 300 for surface through 3, so that's pretty decent there. Alright, so this is probably a good time to take a look at chat and bring up the satellite. So there's what things look like this evening. Let's see how things are going in chat. Kind of a quiet night. We're in the middle of the week. David Lumbert, Maumelle, Arkansas, 80 degrees. Got Electric Dog here, and Erica Baker, 82 degrees. Enjoying the forecast. Superman, thank you. I appreciate that. There's Willie Greenway, getting thunderstorms in that area, and you probably saw in the opener there I had some close-up GOES-R footage of North Georgia. David Moore, upper 80s there. Northwest Texas, hopefully some storms by Sunday. We got Burl H. and Funwood Tech, Chris Tyne, Carl Berghoff. David Moore liking the opening. Brett Dean there with allergies in southern Jersey. 70 degrees there. Michelle Curlin up in the hotel in Chicago. That's always a lot of fun, getting up in those high-rise hotels. So glad you're enjoying that. Adam Davis, looking to turn to the forecast books. Very good. And Christian Flock, beautiful evening in Yukon. Sue M joining us. Brett Dean says hit the like button. And very good. So, how are y'all doing? Everybody doing good? I got a really good shot here. Let me zoom that in. This is going to flicker, of course, as we roll this through, but once it finishes the loop and plays over again, you'll see it a little bit more clearly. But this shows these storms rolling out of Wyoming into Nebraska. And this is very common this time of year when we have that southeast flow affecting the area. On the opening clip, you can really see these storms get going. I'm going to back this up, and you can see that they're coming out of the mountainous areas. Cheyenne is right in this area here, and there's some mountains out to the west. And these initially formed orographically on those mountains there. There's not too many triggers out here, plus you have the strong cap. And you'll get some elevated storms going, but getting sustained surface-based convection, that's the real trick there. So we kind of had to wait for a lot of this convection to roll out of Wyoming this afternoon here. So let's roll that forward. You can see those cells coming out of there, lots of multi-cells that cross over into Nebraska. And we can see some interesting structure there. You can see a little bit of back shear on the anvil right there. There's the stronger tops, the overshoots, and then we can see the other cells on down to Colorado. So probably some very good visibility out there. You could probably see these all the way from Wikini or out in this area. There's some good visibilities. You can see these storms from easily 100 miles away there. All right, so let's go back to the, let's see, what else are we going to look at? Oh yeah, I forgot one other thing here. This is probably a good time for it. Alright guys, time to take a look at journals, so let's do that. Alright, so I'm going to go ahead and pick up the rest of this part 2 of convective modes, and we'll just take a quick look at the rest of the graphics. We're only going to look at maybe about 6 or 7 graphics here, but I want to kind of wrap up what we were covering yesterday. So we went over this other stuff in yesterday's webcast. We saw that instability by itself is not that great of an indicator. There's most unstable CAPE right there. And pretty much all the different categories, they kind of spanned a wide range of CAPE values. So what do we need to use to forecast and differentiate all the different convective modes and tornado intensities and so on? So let me scroll down to about 2/3 of the way through. Yeah, here we go. This is kind of a set of different graphics. Now, the black line, see this black line on the bottom, that is your quasi-linear convective system or squall line significant tornadoes. And then the gray here, those are going to be your discrete tornadoes, or your discrete cells with tornadoes there. So those are basically the right movers that are kind of isolated there. And then, again, the black ones, the black lines here, those are the QLCS storms there. And you can see that it's divided up between winter, spring, summer, and fall. So let's kind of take this a little bit at a time and start with winter. Okay, so it's winter time. Let's say you're trying to get an idea of what kind of convective modes are going to form later during the day. So we're looking at mixed layer CAPE. Is mixed layer CAPE, is that a good value to use? Is that a good parameter? Well, keep in mind that overlap is a bad thing. You want to have separation between two classes like we see right here. See that separation between this box and that box? That's indicating that they fall within different ranges. So basically, if we have mixed layer CAPE below 500, if everything else is looking good, that might indicate that we are favoring linear storms. And then above 500, that would suggest maybe statistically we're looking at better odds of discrete storms. So that's some fairly good discrimination there. But let's try LCL. That's very poor discrimination. The QLCS storms and the discrete storms, they almost match there. Here we have a little discrimination with convective inhibition. Looks like the linear storms like more capping, and that's because they are probably associated with stronger forcing, with those strong short waves coming out and fronts and so on. The discrete storms like isolated supercells, those are going to need a little bit more help from the synoptic scale environment. Storm relative helicity. Yeah, there's a fairly good discrimination between the two types during the winter time. But I really think, that goes back to that CAPE is probably a much better measure. And then we have the bulk wind difference right here. There's some overlap there. But in the lower ranges, we're kind of favoring linear storms. And the discrete cells, those need faster flow. And then that leaves us with significant tornado parameter. So nothing particularly great here. The discrete cells, they need higher values of STP, but pretty much anything below 1, that kind of favors linear storms. So that's how we go about using this, and I'm just going to go very quickly through the remaining ones for spring, summer, and fall. With ML CAPE, as we get into the warm season, the values go way up, and not surprisingly, your isolated supercells, they favor the higher values. LCL height, they fall pretty much in the same range there. So your LCL, that's going to be better for finding non-tornadic versus strong tornado environments, but not linear storm versus discrete right mover. Convective inhibition, nothing too significant there. Storm relativilicity. What does this tell us? Well, we tend to have higher values of storm relativilicity with the discrete supercells. Apparently the linear storms don't need as much storm relativilicity. Bulk wind difference, similar pattern there. And then significant tornado parameter. There's a little discrimination here. Basically below 1.5, you're looking at more of the linear storms, and above that, with the instability becoming very dominant, we see those STB values going up quite a bit. So this can be kind of important because your long track tornadoes tend to be associated with your long-lived supercells, especially out in the Great Plains. A lot of your damaging storms are from the isolated supercells there. And those are going to be up in the upper part of this STP range. So basically, when you get above 1.5 to 2, that's a good indication that you really need to be on guard there for those storms, especially during the warm season. So basically, between supercells and linear storms, there's not very good differences there, except for that cape. And that's probably about all I want to cover there. Let me just check my notes here. Yeah, that comes back to another point there. You know, I've been showing you how there's not too much here that discriminates non-tornadic, or I'm sorry, discrete versus linear storms. It's much easier to find non-tornadic versus tornadic environments, but when you get into this storm mode, discrete versus linear, this kind of hammers home that there's very little at the synoptic scale, like we see here, that can really help you. You're basically coming down to hand analysis and satellite and predicting storm motion relative to the boundaries. There's a lot of really subtle stuff here that you have to keep up on to be able to do that kind of forecasting. So all these indices, these will definitely help you predict tornado potential, but to get more detailed than that, which is important for chasing, because you have to know what types of storms are going to form, then you're going to have to get a little bit more inventive than some of the stuff we see here. So anyway, this is a good basis for that, and it's a great climatological study. And just to recap, this is from Weather and Forecasting, Volume 27, 2012. And this is Thompson, Smith, Grams, Dean, and Broyles. Convective modes, part 2. Okay, so let's go ahead and pick this up and go into the forecast. Okay, so what are we going to be seeing tonight? Well, we do have a little bit of upper air support. If we look in the upper levels, this is what it looks like out there right now. This is the 500 millibar chart. So we've got the polar front jet coming out of Utah, across Wyoming, and into Nebraska. And there's probably a jet max right about there. So we do have energy coming out of the mountains there. And what this means is that when we look at the forecast, chances are we've got a little bit of synoptic scale support here, and this could keep storms going overnight. So this is what I'm looking at the potential for, especially with that front extending out into Nebraska, down the Platte River there. So yeah, the storms do keep rolling eastward. Looks like by 10 or 11 p.m. they're going to be going through around, I don't know what, think I've forgotten some of the town names in there. Yeah, I'm drawing a blank here, but central Nebraska. And then they'll be coming up to North Platte around midnight, and then towards Omaha around 5 or 6 in the morning. So they are going to be rolling eastward overnight, and this can be important for tomorrow because the tail end down here, see that tail end right there, that can be laying down a boundary overnight. And depending on which way that moves, that can affect the storms that we have tomorrow. Now that can be wiped out if there's a front that's bolting southward really quick. That can basically undercut the boundary, but in a weaker type of pattern, especially in the early summer, those boundaries, you really want to keep track of those during the overnight hours. And sometimes I'll go to the radar and I'll pull up like an 18-hour loop, and I'll kind of see where all the convection was overnight. So MCS moving into Iowa and Missouri tomorrow morning, and that should start dying out. They tend to do that during the late morning. So that's not really going to get into Illinois very far. And then here's our setup for tomorrow. Got a low right there in west central Kansas. Looks like we've got cold air coming down across I-70. Cold front somewhere in this area right here. Warm front somewhere in this area. And that warm front could be kind of superimposed with an outflow boundary. So this is the setup for tomorrow. And of course we have the moisture streaming northward. And it looks like most of the moisture is kind of heading into eastern Kansas there. So for tomorrow I do see some potential there for eastern Kansas. So this brings the upper level patterns back into play. Let's check that out. By dawn, here's the pattern that we have. So it looks like we have a jet right across that area where the MCS was. Looks like we have a little bit of maybe some ridging right in this area. And then the upstream troughs, I think those are back still out to the west. So I'm not too sure how much upper air support we're going to have. You can see how I'm using these charts. I'm looking at things in the morning and I'm trying to anticipate what's going to come later in the day. So when I roll them forward, I can kind of see if that matches up in my head. So yeah, it does look kind of weak out there as far as dynamics. I can see a little bit of anticyclonic turning in the height lines right there. So I think there's somewhere in here there's a little bit of weak ridging, but it's not clear to me if there's any strong shortwaves coming across Kansas tomorrow. So it looks like the help is going to be kind of subtle from the upper levels. And yeah, another way you can figure this out is to roll it back and forth. There's 12Z. You can see that at 15Z, Kansas looks pretty white there. So we're looking at low vorticity values. By 21Z, they're kind of low, but it appears there's higher values coming into western Kansas. And then by 0Z, yeah, that would indicate maybe a shortwave approaching from Colorado, maybe out in this area right here. So as that shortwave moves eastward, we see the vorticity kind of increase there in western Kansas. So it appears that we're going to be under ridging across much of Kansas tomorrow, but as the afternoon wears on, we'll get some lift approaching from the west. Wow, look at this very strong jet max there in California there. Good channeling and good packing of that height contour pattern there. So that low is going to settle in over the weekend. There it is on Saturday. And then we get into Saturday's setup. Wow, now the plains are starting to get close to this cyclonic flow. So we're going to start coming under the influence of this deep trough as the day goes on Saturday. 18Z, 21Z. It looks like we're still under ridging on the Great Plains. And then let's see how things look on Sunday. There's Sunday morning. Still some ridging, but it looks like it's exiting finally. And now we're going to start seeing some of these waves moving out of the Four Corners area. So this is how it looks for Sunday evening. Good chance of some assistance from upper level forcing there for Sunday storms. Looks like a little disturbance off the coast of Florida right there. So maybe things kind of unsettled in that area, maybe into Georgia. And then let's go into Monday. Still got southwesterly flow there. That's kind of a good setup there for storms. You always want to have that troughing out there to the west. So it looks like we have a few days of storms. Here comes a good trough on Wednesday. A little bit of a break around Thursday next week. See, there's some ridging right there. Here's the ridge. And that other area that I drew right there, that's subsidence. Then we have this very compact cutoff low in the San Joaquin Valley for Thursday. That kind of moves down the coast. And then into the Four Corners area for the weekend of the 18th, 19th, and 20th. So it appears we'll have a bit of a chase weekend possible in the high plains, and maybe coming out into the lower plains for Sunday and Monday. And here comes another trough for the following week, 21st, 22nd, and it appears that'll affect mostly the central plains. And then we open up some zonal flow, again, central plains, and then we have, yeah, this is a tropical system coming up from the south. I'm going to show you that in a minute. So let's put that together and look at the forecast. Starting out, you can see the weak moisture, lots of 50s and 60s dew points, but that's going to improve overnight. The purple is the 70s dew points, the cyan is the 60s dew points, and you can see we're starting to fill in the darker cyan right there. So we're coming up into the mid and upper 60s dew points around Interstate 35 there. So this is the setup for tomorrow. You can see the moisture axis from about Dallas up to Oklahoma City and up to about Omaha. And we know from doing that analysis that we've got our low there in central Kansas. Looks like it's migrated up to north of Salina. So the setup we're going to have tomorrow night or tomorrow afternoon is going to look something like this here. Let me try that again. There's our warm front, cold front out to the west there, and there's our dry line. It extends from about Salina down to Woodward. So a couple different possible plays. One is along the dry line around Great Bend. Another area around, let's see, that would be north of Salina to north of Kansas City. That's along the intersection of that moist axis with the warm front. And another area possible is upslope, Kansas and Goodland. You can see the 60s dew points making it to the Goodland area right there. So there could be some good storms in that region. And let's sample the air mass around Topeka. This is around 18Z. We can see our loaded gun sounding there. We can see a very strong cap, unfortunately. That cap, that looks kind of potent there. In fact, you can see the temperatures at 700 millibars are around 12 to 13 Celsius. So that capping may keep things shut down. We'll have to see what kind of precip breaks out there on the GFS. And looks like the wind flow aloft is a little bit weak there. Not very elongated, but a little bit of 0 through 1 kilometer shear in there. A little bit of upper air support helping to back those winds would make all the difference. So by evening, looks like that little low moves up into southeastern Nebraska. So that'll probably carry with it the possibility of severe weather, so maybe extreme southwestern Iowa and adjoining parts of Nebraska and Missouri for tomorrow night. And also, yeah, around Goodland out to Burlington, upslope storms, and then we see the dry line down here, but I think that cap is going to be a little bit too strong. Here's a sounding around Pratt. I don't know, it looks a little bit weaker in there, so things may come together. Let me take a look at the NAM, see what breaks out. There's 18Z, there's 21Z, and 0Z. Interesting, they got a little bit of convection down there along the caprock in Texas, but as you can see, not much going on there in southeastern Nebraska. And even by 3Z, nothing. So I guess that cap is really messing things up out there, but in Texas, I guess we've got a little bit of a weakness there. A couple of cells showing up in that region. And we'll go ahead and take things into Saturday, see what things look like. That cold air will kind of seep south into Kansas. So by evening, we're going to have a boundary kind of like this. Still bringing up the moisture, but the model does not break out any precip. A little bit of elevated stuff up in this region, but I guess once again we're having problems with that cap. We'll look at a sounding around Emporia, Kansas, and yeah, there's that cap right there. 12 Celsius at 700 millibars. And let me do a manual lift of, say, 88 degree air. It's pretty well capped there, so we would really need a strong boundary, a good meso-low, or a strong shortwave to get things going over the weekend. So we'll probably just have to evaluate things tomorrow and see how things look for the weekend. But going into Sunday, things sink south right there, and we do know that the capping looked a little bit weaker as we go west. Looks like there's also a little bit of lee side troughing there in northeastern New Mexico. And that sets the stage for a little bit of deep convection there in the northern Texas Panhandle. So Sunday could be the best day there this weekend. And then let's bring things up into Monday. Going to have to go to the GFS for that one. Okay, so you can see that that cold air sinks south very weakly towards the Texas Panhandle. And we've got a little bit of a different picture here on the GFS. The NAM was bringing that boundary all the way down here. And the GFS going for a little bit more northerly position right there. Dry line intersection right around Pratt. And that would suggest maybe storms a little bit further north. So a little bit of uncertainty anywhere in this area here for Sunday for severe weather potential. Then we go into Monday. Look at that, a little wave coming together out in western Kansas. So this would be a short wave coming in and helping to generate a little bit of lift. So by evening, we got some decent convergence there in western Kansas south of Russell. So that would probably be the place to be. Then going into Tuesday, once again, looks like a little bit of forcing there in southwestern Kansas, helping to shape the wind field in that region. So yeah, a couple possibilities. And then for Thursday, same deal. Kind of a multi-day event, and you can see the dry line moving off the caprock and into western Oklahoma there. And 70s dew points finding their way up into Kansas. So you can't totally give up on May. As Tim Marshall always said, when it's May, you chase. And it's really hard to write off things in spite of how they look in the long term on the GFS. So there's our little low right there on Thursday the 17th. drifting northward. And then for Friday the 18th, that little low moves up into Iowa, and we reform a new cyclone out to the west there. So some possibilities out in this region and maybe up in Iowa for the 18th. And then we get our strong front coming out of Canada right there. Looks like some more potential there on the high plains over the weekend of the 19th and 20th. You can see the pattern comes together really well right there, so it looks like we've got some strong upper level dynamics for the weekend. Saturday the 19th there in western Kansas. Yeah, every day is like Kansas, Kansas, Kansas. So there goes that low right there. Things redevelop out to the west there. And this is where we start seeing that tropical system coming in from the south. Let me shift your attention down there. You can see how the wind is kind of turning around there in the Gulf. And if this actually happens, this could mess up our moisture flow for at least a few days there in the southern plains. This isn't really a very common thing in May, obviously, but the GFS yesterday was focusing on moving that up towards Louisiana. Now it's moving that system up towards Florida. So this could be either a tropical storm or a hurricane if this actually pans out. This is still 2 weeks away. This is like the 24th, 25th. The European model was not really reflecting this, so take this with a grain of salt, but from run to run, the GFS has been pretty consistent with developing this thing off the coast of Belize and basically from Nicaragua up to Belize and then bringing that north. So we'll have to continue to watch that, and we've still got at least 7 to 10 days to refine this forecast here. And towards the end, 26th, looks good for Kansas there. So not a whole lot of severe weather for Oklahoma or Texas, but definitely looks not too bad for Kansas and maybe Nebraska. Okay, one last look at chat. Let me just kind of skim through here. Oh yeah, Fun with Tech, appreciate that, giving us a link to that paper. Reed Timmer reporting Epic Mothership. Yeah, I forgot about the radar. Let's look at that. Reed Timmer is in Nebraska. Okay, thanks to Best Weather PT. It's going to be one of those storms. Looks like that sail out there in Colorado has dissipated. Shows you the very fickle nature of these low moisture cells. See how that one just kind of evaporated there. And then further up north, this is up towards McCook. Some pretty good cells there. Let's take a look at the velocity and see if any of those stand out. And I think for this we're going to have to kind of subtract out some of the storm motion, so let me do that. I'm going to go for maybe 240 at 40. Okay, a little bit of range folding in here, but yeah, this one appears to have a circulation there. And the others, the problem is as you go this far away from the radar, you're getting more into the upper parts of the storm, but for just kind of a quick glance, this can kind of tell us where to look, especially if you're close to the radar. So there's one cell. Let's see how that looks. This is going to be, let me get my bearings. Yeah, that's going to be about 20 miles southwest of North Platte for this one storm here. So the algorithm there going for 1 1/4 inch hail. Bobby Conway reporting strong mesoscale line moving through Greenville, North Carolina, 79 degrees. Congrats to Fred Reamer, finals are done. Adam Davis wonders how many chasers forecast by seeing what Reed posts on social media. Yeah, that forecast technique is as old as the hills. People were doing that back in the 90s, getting on the mailing lists and using that for targeting. So just a fact of life there. Superman wears a cape. Good point, Fred Reamer there. And Best Weather says, could it be that tropical system later in the forecast period? Could it feed some moisture to the plains? Well, not really. It's going to consume some for itself, and the broad scale circulation is going to cut down that southerly flow out of the Gulf and shift it to more of an easterly or northerly component. And that does have an effect on the moisture supply. Later in the spring, evapotranspiration becomes more important, which means you can kind of feed the air masses from all the vegetation and crop fields and so on. And that's what happens up in the northern plains a lot. That's pretty helpful, but the very deep moisture with deep upper 60s dew points, that's going to be tougher to come by in Texas with a system out in the Gulf of Mexico. Carl Berghoff says, remember to like, and says you can right-click a warning to set the vector. Good point. All right, thanks everybody for joining the Forecast Lab. Hopefully we'll see you all tomorrow, and we'll update you on the storms over the weekend. Until tomorrow, have a good evening. Thanks.